Hi, in this video, I will be explaining you on problem number 4 from chapter 12, section 1. This is about projections of a point in space. What are the projections of the point 2, 3, 5 on the xy, yz and xz planes? Draw a rectangular box with the origin and 2, 3, 5 as opposite vertices and with its faces parallel to the coordinate planes. Label all vertices of the box and find the length of the diagonal of the box. Here the concept is that if you take a point P with coordinates x, y, z, and if you project it on the x, y plane, then the z coordinate will be 0. So the projection of the point on the xy plane is the foot of the perpendicular from the point to the xy plane. So the x and y coordinate will remain the same and the z coordinate will become 0. So the projection of the point on the xy plane is 2, 3, 0. Same way, projection of P on the yz plane is the foot of the perpendicular from the point P on the yz plane. On the yz plane, any point will have its x coordinate 0. So it will be 0, 3, 5. So projection of the point on the xz plane is foot of the perpendicular from the point P to the xz plane, and any point on the xz plane will have its y coordinate 0. So it will be 2, 0, 5. Next part of the problem is to find out the rectangular box corresponding to the point P, 2, 3, 5. So x coordinate of the point is 2, y coordinate is 3, z coordinate is 5. So let's draw the coordinate axis xyz as shown in this figure. Then we mark 2 on the x, 3 on the y, and z on the z, 5. So now we are going to do 2 units along the x and 3 units along the y are in a direction parallel to y. So move 2 units, 3 units along the y direction. So it's actually on the y-axis it is 3. Now we are going from the point 0, 2, 2, 0, 0, that is the point on the x-axis, towards the direction of y-axis through 3 units. And then we are going to move above 5 units along the direction of positive z-axis. That's 1, 2, 3, 4, 5 on the positive direction of z. So this point, first point that we took is 2, 0, 0. Then the second point that we are taking on the xy plane is 2, 3, 0. That is the projection of the point on the xy plane. And then we have the third point, which is our point 2, 3, 5. This is the point on the space. So this is the point P. Now we have to complete this rectangular box. Now we will find out the foot of the perpendicular of the point P in every coordinate plane. So the foot of the perpendicular P on the xy plane that we just discussed is 2, 3, 0. On the yz plane, the foot of the perpendicular is x is 0, x coordinate is 0, y and z stay as they are. Then on the xz plane, the foot of the perpendicular will have its y coordinate 0, so it is 2, 0, 5. So these are the points, and we have completed the box. The rest of the points on the z-axis, it is 0, 0, 5. On the y-axis, it is 0, 3, 0. Now, the last part of the question is asking us to find out the distance between the origin and the point P. So the distance OP is, by the formula, it's an extension of two-dimensional formula, which is x1 minus x2 for 3 coordinates, x1 minus x2 the whole square, y1 minus y2 the whole square, plus z1 minus z2 the whole square. We can consider one of the points as P, x1, y1, z1 as our point P, which has coordinates 2, 3, 5, and x2, y2, z2 can be considered as the origin O, which is 0, 0, 0. So the formula becomes 2 minus 0 the whole square plus 3 minus 0 the whole square plus 5 minus 0 the whole square. It shall be square root of 2 square, which is 4, 3 square, which is 9, 5 square, which is 25. So which is square root of 38, which is approximately 6.16. Hope this video helps.